Hello everyone, this is the first lesson recording for IM2, September 24th, 2020. What are we doing today? We are going to be defining congruence for polygons, and we are going to study triangle congruence. So when we talk about congruent polygons, the definition of congruence is that two polygons are congruent if there is a sequence of rigid transformation that carries one onto the other. So if you have this shape here and another polygon shape here, if we can transform this polygon to map exactly onto the other, then we would say they are congruent. Or we can use reflection, or we can also use rotation. They are all transformation, all combination of any. Okay, so if you can perform any transformation to map one shape exactly onto the other, yes, they are congruent. But the working definition is that when two polygons are congruent, then all the measurements are the same. All corresponding sides have equal length, and all corresponding angles have equal measures. So what do you think about this polygon? Okay, this is how many sides? 1, 2, 3, 4. Four-sided shape, so it's a quadrilateral. And now, does it fit the congruence definition? Do they have all the corresponding angles having the same measure and all the side length having the same measure? Yes, they do, because 12 matches up with 12 here, 15 matches up with 15, 30 matches up with 30, and 27 matches up with 20. Also, we need to match up the angles. The 132 is between 12 units and 15 unit size. So between 12 unit and 15, it's 132 as well. Okay, and then between 15 and 30, it's 47 degrees and 47 degrees here, so the angles match up there. And then finally between the 30 unit and 27 unit, it's a 41 degrees and 41 degrees here. So, and then last one also should match up too, if all three are matching up. Okay, so yes, they are congruent because all the angle measures are the same and all the side length are the same, the corresponding side length are the same, almost as if you can rotate this onto the shape on the right. Okay. All right, what about this one? What do you think? Okay, please pause the video and tell me what you think. Are they congruent or not? Okay, well, they have the angle measures of 90. What about this second shape? Well, not quite the same, huh? Right? So 91 and 90, two different numbers. Even if it was 90.001, there will be two different numbers. So it's not going to be exactly the same. So therefore, these are not congruent. In fact, this is a square because they are all 90-degree angles. And this is a rhombus. Even though they have the same side length, this is rhombus because this is not 90 degrees. Okay, and the moral of the story here is that you can't trust your eyes. You've got to check all the measurements or any notations. Okay, so are they congruent or not? Please answer in private chat. Can we transform these two shapes to be map onto one another? The answer is yes. We can do a rotation. Alright, so now we are going to go from the polygon congruence, more focus on studying triangles. Why are we doing that? Because triangles are the simplest polygon. You only have 6 measurements to check. You have 3 sides and 3 angles. And any polygon is made up by multiple triangles. So for example, this pentagon 5-sided shape is really made up by, you can divide that shape into 3 separate triangles. And hexagon here, 6-sided, can be divided up to 4 different triangles. And octagon here can be divided up to 6 triangles. Okay, so any polygon can be made up by multiple triangles, and that is the reason that we spend so much time on dealing with triangles. Alright, so before we get right into it, we're going to go into symbols and notations. So you can tell that these two triangles are congruent because they have the same corresponding angle measures and then same corresponding side length measures. Okay, so we can describe the congruence using words and numbers, but we can also use notations and symbols. So, and notations and symbols looking like this. So when to say that this angle D is congruent to angle C, I would put one arc there, one arc here, to indicate that angle O is congruent or same in measure as angle A. I will put two arcs here, and then angle G and angle T are corresponding and they are congruent. Likewise, for the side length, we'll put notches. This side length is congruent to this side length because they have one notches each, and this side DG is congruent to side CT because they both have two notches. That means those two are equal in measure or congruent, and this OG is congruent to AT. Okay, and we can say in words that these two triangles are congruent, or we can write that triangle DOG is congruent to triangle CAT. My dog would not like this idea that dogs and cats are congruent. Alright, so congruent statements for triangle is naming the triangles in the order of congruence parts. So the order is very important. So you need to match them up. So angle A matches with angle E. So you will make sure that they are in the same position when you're writing the congruent statement. By the way, this is a congruent statement. When you say triangle so and so and so, this is a congruent symbol, is congruent to triangle so and so and so. Okay, and we use the three vertices to name the triangle. Okay, so triangle ABC is congruent to triangle EFG, and angle A corresponds to angle E. That's why they're in the first letter being identified, and then angle B corresponds to angle B. That's the middle letter, and then finally angle C corresponds to angle G, or you could even say vertex C and vertex G. They correspond to each other, and so they are the last ones on the statement. Okay, and also the congruent statements for triangles naming triangles in order of congruent parts. That means we also need to make sure the side length, sides of the triangle also correspond. So side AB correspond to AF, right? So AB, side AB corresponds to EF. So they should match up. Likewise, BC should match up with FG. And finally, the AC should match up with EG. Okay, all right, so okay, let's do some practice. So this time, given these triangles and the notation, you're going to write the statement that indicate each triangle part congruent. So in this case, are the triangles congruent? First of all, what they are, because all the corresponding sides and the angles, they are congruent. Oops. Okay, so then we need to write the congruent statement. So we need to say triangle. We need to go from the left triangle here. We can start with, maybe I can match up the vertex V, because that's the one with one arc. Which is the one with one arc on the other triangle is I. Okay, and then second 2 arc vertex is W on the left triangle, and on the right triangle is H, and on the left triangle the third vertex with the 3 arc is X, and on the right that's the J. So I know that triangle VWX is congruent, that's the symbol, equal sign with a curly line at the top, is congruent to triangle IHJ. That's what you should have. Okay? Alright, what about this? This time you're given that this triangle XWV is congruent to triangle BCV. Now this time I would like you to try to mark the angles and sides of each pair of triangles to indicate that they are congruent. Okay, so triangle XWV. X corresponds to this, so I am going to mark this as X. Okay, X corresponds to B, so I know that X corresponds to B, so I am going to mark it here. Okay, just because they kind of look like X should match with C, you cannot do that. You need to go from the statement here. Okay, and then let's do another color for W matches up with C. W, vertex W matches up with C. Okay, so and then finally let's do green. Okay, V matches up with B. Okay, alright, so then we have marked them. Now, which is the corresponding side? Well, I can actually, the easiest way is to think about, okay, the one that is opposite this green arc is this one, and the side length that is opposite that green angle is this one. And the blue, the side that is opposite the blue angle is this one. Opposite just means across from. And then finally for the red angle, the side that is opposite, I am going to mark it with 3 notches and 3 notches here. Okay, that's the easiest way. Alright. Alright, so now we are going to be thinking about triangle congruence, the challenge. Okay, everything, Albert Einstein said everything should be made as simple as possible, but not simpler. Okay, think about it and see if you can tell me what you think Albert Einstein really meant by this. Alright, the driving question is, do I really need all 6 pieces of information to decide 2 triangles are congruent? Can I do with less than 6? Well, in this case, can use triangle sum to calculate the missing angle. Okay. Alright, so actually there is no missing angle. There's a typo here. Okay, alright, so in this case we have all the angles are the same and all the side length, corresponding side length are the same. So the side length opposite 63 is 12. The side length opposite 63 degrees is 12. The side length opposite 42 degrees is 9, 9 units, and the opposite 75 degrees is 13. Okay, so we know that not only the angle measures are the same, but the corresponding side length are the same. Okay, you do need to match them up as in across, because sometimes it will be the wrong side that's going to be the same. Okay, alright then, but do we all need all 6? No, we do not. That's too much information. Okay, so we can always find the missing angle by using the triangle sum. So if you're given 2 angles, we know how to find the third angle. Okay, if you're just given 2 angles, we know how to do that. Okay, even if this 75 degree was missing, but we had the other angle here, then we would be able to figure out this was 75, so on. Okay?